There are three ways to spell a constant in C, and they are not equivalent. Start with the one you should reach for first, a const variable. Const double pi, const int max underscore users. Three things make this the default choice. It is typed, so the compiler knows pi is a double and will check every use of it, and will tell you if you accidentally pass it where an int was wanted. It respects scope, so a constant declared inside a function belongs to that function and cannot collide with anything else, and one declared at file scope with static belongs to that file. And it is visible to the debugger by name with its value, so when you stop in the middle of a calculation you can ask what max underscore users is and get an answer. None of those three things is true of the preprocessor alternative, which is where we are going next. The second way is a define. The preprocessor runs before the compiler proper and does exactly what it looks like wherever the token pi appears in your source. It is replaced by that string of digits textually before the compiler sees a single line. That is why it is untyped. There is no variable, there is no storage. There is nothing for the debugger to know about. Ask a debugger what max underscore users is and it will tell you there is no such symbol, because by the time the compiler ran, there wasn't. It is also scope-free. A define is in force from the line it appears on to the end of the translation unit or the matching undef, ignoring braces, functions, and everything else. That is why the convention is to shout them in capitals. The capitals are a warning that ordinary scoping rules do not apply. So why keep it at all? Because in two places you have no choice. In C89, an array size had to be a define. And anywhere the value must be a compile time constant expression, a case label, a static array bound, a preprocessor if a const int will not do, and a define will. And here is the reason function-like macros have a bad reputation. Because substitution is textual, the arguments arrive as raw token sequences with no brackets around them. Look at bad_sq. Call it with 2 plus 3 and you get 2 plus 3 times 2 plus 3, which by the ordinary precedence rules is 2 plus 6 plus 3, which is 11, not 25. The macro did not multiply the argument by itself, it multiplied the last token of the argument by the first token. The fix is to parenthesize every single use of every parameter and to wrap the whole body in another pair, which is what SQ does, and now the expansion has the brackets it needs and gives 25. Do that always, even when it looks unnecessary, because you cannot see the call site from where you write the macro. And there is a second problem the brackets do not fix: double evaluation. SQ of I++ expands to 2 increments, so I goes up by 2 and the result is not the square of anything. A real function cannot do that. That, more than anything, is the argument for const and for inline functions. The third way, and the best one when you have a set of related integer constants rather than a single value. An enum declares a list of names and gives each one an int value. Left to itself, it numbers them from 0 upwards, so red is 0, green is 1, blue is 2, and adding a fourth color later just works, with no numbers to renumber by hand. Or you can assign values explicitly where they mean something outside your program, as with those HTTP status codes, and you can mix the two. Any enumerator without an explicit value continues from the one before it. What you get for using an enum instead of 3 defines is real. The enumerators are genuine int constants, so they work in case labels and array sizes where a const int would not. They are visible to the debugger by name, so a variable holding 1 prints as green rather than as 1. The compiler can warn you about a switch that forgot a case. And the names are grouped under a type, which documents that they belong together. Be clear-eyed about one limit, though, in C, unlike C++, an enum type is not really a separate type. You can assign any int to it and the compiler will not stop you.